So the first time I ever came to Australia was in 2010. And it was actually for the YOW conference. And I took a little bit of time. I was like, well, I'm flying around the world. I'm going to take a little bit of time to see the country. I went up and spent the weekend in the Glasshouse Mountains, up, I believe they're north of here. And I was staying in this little bed and breakfast. And I woke up in the morning, and the guy who runs the place, he goes, oh, come here, come here. Except in Australian. And I go, okay, and I go into the kitchen, and there's a glass turned over on the counter. And he goes, oh, you got to see this. I found this morning. And I'm like, oh, cool, you know, Australia, it must be cool. And we walk up to it, and holy shit, it's a spider that's like this big in this glass. And I'm like, what the? And he's like, yeah, I was wandering around the kitchen. And he's like, I caught it. I thought you'd like to see it. And this is a bed and breakfast that I'm staying at. And so he goes out and he puts it on like a cistern with some lily pads. I mean, those lily pads are like 8 inches across. And I'm like standing about 10 feet back trying to take a picture of it. Whoa. And he's like, no, come here. And he takes the camera and he gets like an inch away from this thing. Now, I don't know what you guys know about Australia, but I've heard that everything here is trying to kill you. And so maybe it's just they try to kill foreigners that are coming in. So this was my first sort of, yay, Australia experience. Luckily, it didn't kill me. So I want to start off with a little bit of a question. Does anybody know who this is? Who? No. No, this is Jean Bartik. She was one of the original 6 ENIAC programmers. She's awesome because her title was computer. And so she was on a team. She and her, you know, back in the day, the computers were women who sat around and calculated missile trajectories. You know, by hand. They were all mathematicians. And she led this team of, you know, really smart women. And they came to her, the people came to her and they said, we need you, we're building this machine. And we need you to learn, you and your team, to program it. And she goes, oh, okay. I don't see why I couldn't do that. And so they actually came out and she's like, where is it? And they came out with a bunch of rolled up paper and laid out the circuit diagrams. And they said, well, we haven't built it yet, but we need you to learn how to program this physical computer. And they laid it out. So her and her team did. And she comes in and they built it. It's the size of like, I don't know, back 20 rooms or something. It's this immense structure. And she and her team's just sitting there programming it. But it's amazing. She like figured out how to program this thing just from the circuit diagram. She didn't have, Ruby. It was all, physically doing stuff, moving. Then they moved it over to be a stored program machine rather than the physical connectors. And I think it was 98 or sometime in 2000, she got inducted into the Computer History Museum's sort of Hall of Fame. And the 2008 Museum Fellowship. And they interviewed her and they asked her, like, what's, it was an 80-foot long, 8-foot tall black metal machine, dozens of wires, 3,000 switches. And they asked her, they're like, hey, weren't you like intimidated by this machine? And so I want to play a little bit.
This machine. Well, yeah, but let me tell you how I really, Betty Snyder and I from the beginning were a pair. And I don't know, many of you work technically, but I believe that the best program is the best design and all this stuff is done by pairs because you can criticize each other and, find each other's errors and gives the best ideas. It really works very well. Well, Betty and I were partners on the punch card equipment, and we were partners on doing the trajectory for the demonstration. But
so I just want to point out one thing. They were pairing in 1946. 1946, they were pairing, deciding that, you know, this was a really great way. You could look at designs and all of this stuff. How many years has that been? 77 years? And we're still arguing about whether or not that's a valid way to program. And I'm not saying that we're arguing whether you should do it 100% of the time, but there's actually arguments out there that it is an ineffective way to program. And for 77 years, this argument's going on. And the fact that we don't know Gene, somebody who is so fundamental in our history, it's a little bit discouraging, I think. So I want to talk a little bit about something I've been thinking about. This is me. This is kind of a running thing. My name's Corey Haines. My company's called Corey Haines, and as it turns out, if you follow it all, my title is actually Corey Haines as well. I do a few different things. I have a video series that I'm starting on clean coders. I'm putting out a product called Hugboard, and as Josh mentioned, I'm sort of a lead sort of troublemaker with code retreats and sort of spreading it around. How many people came yesterday? There were a few people out there. Awesome, I see people I recognize. Cool. And of course, if you follow me on Twitter at all, pretty much my entire stream is filled with pictures of my cat. Zach, there she is laying in front of the fireplace. How many people know this guy? This guy I would expect most everybody to know. Hands up, who knows who this is? Anybody? Yes, it's Tom Selleck. This is Alan Kay. Anybody heard that name before? Yeah. Alan Kay, generally considered father of small talk. There was a few other people around, very influential as well, but generally we think of him as one of the primary people behind Smalltalk, came up with the term object-oriented, of course won the Turing Award in 2003, which I wonder, if you win the Turing Award, does that make you Turing complete? Because that would be pretty cool. Well, I was reading a paper from him, or watching a talk by him, and he was talking about sort of the history of OO, and where it came from, where the ideas came from. And people were like, oh yeah, you came up with this wonderful idea of objects and encapsulation and stuff. And he told this story about the real father of object-oriented programming, the real creator of the ideas. He said it was an unknown, he doesn't even know who it was, but I think it was a lieutenant in the Air Force. And what they used to do is they would send data tapes back and forth. They would send reels, magnetic tape, physically back and forth to each other that had all the data on it that they were trying to work with. And one time, they always had this problem where you would get the data and it would be in some format. You'd have to, read the documentation that came with it, or something that said, okay, here's where the records are, here's the length, here's how you read the file, things like that, the encoding, say, because of course they had Unicode back then. And he said one time they got this tape in, and he noticed something interesting about it. So in 1961, he gets this tape, and rather than having a bunch of documentation or other stuff about how to program in the retrieval functions, actually the tape consisted of the first part had a set of pointers and set of addresses that indexed into the next part, which actually contained the code itself for accessing the data records. And that's pretty cool, because that sure does sound like an object. It sure does sound like the stuff that we kind of work, what kind of lies underneath. And it's pretty neat that back in, all of these things had sort of this really innocuous, just the origins were just, some guy in the Air Force was like, wow, that really sucks always having to type in the programs. Why don't I encode that with it? And that's 62 years later, we're still talking about it. Let me hope that, oh no. Where's Michael? His password?
This is social engineering.
Yes. Oh no. Oh well, I'll keep talking about this. So it's intriguing that we have that all of these things have this foundation so far back, and we've lost touch with a lot of it. We've lost touch with where the stuff that we do comes from. And by losing touch with that, there's that saying that if you don't remember history, you're doomed to repeat it. And that's kind of true, because we have the same sorts of arguments that you can read in the literature about, whether or not functional works, or whether it's better, or whether OO is better. We have all of these discussions. I've seen arguments that, the only reasonable response is like, hey, the 90s called, they want their arguments back. That we keep having these. This is just one of my favorite phrases from Alan Kay. If you haven't watched his Uppsala 97 keynote, it's well worth watching. Lots of really interesting stuff about his thoughts behind it. But we go through these changes, and we don't have a great way of sort of conveying our history down to us. We tend not to pay much attention to our own history. We talk a lot about how our industry is young, and we use that as an excuse to sort of make up things and ignore where we come from. And this is Bruce Tate's wonderful book, 7 Languages in 7 Weeks, makes this comment that many of the readers of this book won't be old enough to remember the last time our industry switched programming paradigms. When we went from a heavy procedural to heavy OO. Now we're sort of going through a little bit of the same rumblings. We're starting to see people, coming up and going, well, functional is the way to go forward. It's got to be Clojure, because that's going to be the greatest thing ever. And we're losing sight of the fact that we already went through these things. There's so much history and so much sort of pre-argued things. So through the rest of the talk, I kind of want to talk a little bit about some of those. Maybe tease you a little bit with some of the neat things that are out there. Anybody know this guy? Anyone? Wager a guess? His name's Charles Hamblin. This guy was one of the ones, he created the stack. The data structure. How many of you know what a stack is? Yeah. How many of you used a stack like yesterday? Amazing. Everything now there's a little, he independently created it, and Turing actually included a form of the stack in a paper that he wrote in 1946. But 1957, Charles Hamblin comes around and he goes, here's a stack. And it's really neat, because if you think about it, everything that we use, everything that we do as programmers, somebody at one point went, you know what, I think I need a stack. And it's not because they went to like a buffet and there were all of the plates on the springs and they thought, man, I could build a data structure like this. It was just, I need this. So Charles Hamblin, he worked on this machine called the Deuce, which, I don't know if that's slang here in Australia, but I figured if I can have Deuce written really large on a slide, I'm going to. 30,300 additions per second, that's pretty cool. And at the time, there were two problems in computing. Only two. And they all revolved around this, computing math formula containing brackets. I mean, computers were not that powerful. It's 1 megahertz. This was the height of the thing. And one of the things was this memory overhead and named memory stores. If you don't have a lot of memory or any memory, just a tiny bit, you can't just be like, oh, I'm going to create 20 variables here. You've got to actually think about these things. And as with Gene, most of the computing power was there to calculate missile trajectories. It was doing mathematics. So Jan, I'm not even going to try. This guy came up with a concept called Polish notation, which allowed you to sort of work without parentheses around things so that you could order things a little more easily for doing calculations and not having to store as much information, store in named slots and things. And it looked like this. Anybody ever done Polish notation? Are you sure? Okay. RPN is what Charles Hamblin invented. And he invented it implementing it with the stack. And of course, it's the AB+. And what it allows you to do is what's called a zero address architecture. Because the way it works is you're pushing these things onto a stack, and then an operator pops off the stack and operates and then pushes the result on. You don't actually have to have memory addresses for the variables. All you need is sort of a push-down, pop-up stack. So it's also known as a stack. I wish I had a picture. How many of you had one of those HP little awesome calculators? Man, that got me through college. We used to throw the thing around the room because I was a math major, so it was lots of frustration. And we'd throw it, and that thing lasted forever. It was amazing. It was one of the first things I really programmed. Here's a question. Another person? This one's actually a trick question. I'll let you know beforehand. This is Carl DeCera. He was my Wing Chun teacher. So how do you guys not know him? He comes from a long line, all the way from the origins of Wing Chun, all the way down to Yip Man and Lung Sheng and Ken Chung and Carl. And then he has some schools. He actually has a school in Sweden, which is pretty cool. Seattle. I did it when I was living in Cleveland, Ohio. Here he is with his teacher, Ken Chung. Here's me. Look at me. I'm the one on the right. Sitting there sparring with my teacher's teacher. That's pretty awesome. Here's Lung Sheng, who taught Ken, all the way up to Yip Man, who is generally considered to be the one who sort of created the resurgence of Wing Chun, which is a wonderful martial art. Just fantastic. One of the big things that hit me about it was that there wasn't really a move for going backwards. Every move in it was intended to go forward and through your opponent. It was very, very brutal. It was developed by a woman because, the legend goes that her village was being attacked by brigands, and they had, all the men were weak, or they had killed all the men or something. And so she developed this martial art, taught it to all the women of the village, and then just mopped up the place of the brigands. And it's an internal, it's very soft, but it's one of the most brutal things I've seen, because you don't move backwards. You just keep going at the person. There's a long line through it. Anybody know who this guy is? It's Bruce Lee. He created the form of Jeet Kune Do. The thing that he learned, that he developed Jeet Kune Do from, was Wing Chun, incidentally. So there he is. He was a fought in the streets and stuff, and so he came in and they put him out there. So this is Yip Man. Anybody know who this guy is? Some of you might know. This is David Chelimsky. He was the RSpec maintainer for, I think, like 50 years. He's since passed it on to Myron Marston, but he's super awesome. I've known him for about 9 years. Met him at a conference, and he's had a tremendous impact on me. A lot of my testing style, a lot of my design sense. The first Ruby I ever wrote was RSpec, because I'd see David and he'd be like, if you've ever seen him, he's always coding. And I'd always ask, what you doing? He's like, working on RSpec. So I'd sit down, and I was doing .NET at the time, and so all of my Ruby was actually working on RSpec maybe twice a year when I'd see him. So he's had this tremendous impact on me. Here's one of my favorite pictures is we pair it a lot when we see each other. So we're like, it's just like this synergy, you know. We're like one person there. This is actually a historical reenactment. But we spend a lot of time pairing. I'm very, very lucky. I live in the same city. He lives about 4 or 5 blocks from me now. So I get to see him periodically and still learn from him as we go in our programming. Here's a gratuitous picture of my cat. Okay, so MongoDB. Anybody heard of this thing? It's the new hotness. It's web scale, I heard. Is that joke like dead yet? No, okay, because I know its age is, it's been years now that we've been laughing about web scale. But MongoDB, is super awesome web scale. It's a document database. And it's really cool, it's a collection of unstructured data combined with various design elements that lets you access and manipulate that data. Anybody used it? Well, you'd have to, because you're probably doing web. This is kind of the power of it, right? Yeah? Yeah? No? I was told, when was it yesterday, that nobody on Australia responds when you say anything. So this description is a pretty good description, and I found the logo. Anybody seen this logo? Yeah, this is Lotus Notes. Lotus Notes is actually a kick-ass document database. I believe that the guy who created Mongo used to work on the Lotus Notes team. Now, if you've worked with Lotus Notes, a lot of people just work with Lotus Notes Mail, which is sort of, how best to put it? I mean, Josh swore a lot, so I don't want to do that. But Lotus Notes itself as the document database was actually quite good. There were some problems with it, and it wasn't, the best. But MongoDB you can look at and see. It's basically just a web scale version of Lotus Notes. But if you've worked with Lotus Notes, it did have some pain points and, locked you in and all of that stuff. And kind of I worked a little bit with it. It kind of made me sad. And whenever I get sad, I look at my cat. So here's a non-gratuitous picture because we want to be happy. Okay, Cucumber. Anybody use Cucumber here? That's pretty nice. Pretty nice. I was looking at Budada, the minimizes translation between the technical language in which the code is written and the domain language spoken by the business, users, stakeholders, project management. Sounds like sort of the yay, Cucumber's great. We can talk about one of the design goals. We hear this a lot. Is to make it possible for non-programmers, such as our supervisors, our managers, all these people, to be able to read and understand. Other people do this, try to do this, and that's one of the great things. And what you're really looking for, what this design goal is really looking for sort of a common business-oriented language. Now, we laugh at this, because it's COBOL. But this was from an Introduction to COBOL paper. Now we have these great languages. I mean, COBOL, for the most part, runs the world. Banks. You know, I worked at one of the major insurance companies in the States, and almost everything was run in COBOL. I mean, it had been running for like 30 years, 40 years, 50 years. I don't know, 50 years. I don't even know when COBOL was created, but I'm going to assume it was in the Middle Ages. But the really neat thing is that we don't think about the fact that COBOL had this really noble, and frankly, I think it succeeded a little bit. This desire that we don't think about is that it's all about maintenance. You know, anybody work on a system that's like 10 years old, 15 years old? Not in Rails, I guess. But most of the time, we're working on maintaining systems. And the emphasis we often sort of pass over and we don't think about is this emphasis on readability, on maintainability. And that was one of COBOL's design goals. And you could just flat out switch it with Cucumber. And you really could say, one of the things that we don't think about is that Cucumber, done well, gives you a tremendous amount of readability, maintainability. You know, when you want to go in and make a change, looking to see, where do I have to make the change? Having it written in a form that we can read and kind of understand, it's hard to do. You know, it's incredibly hard to do. But it's about knowing, and if we take and look back at like COBOL's design goals, and look at some of the decisions that were made with COBOL, we can bring those lessons forward and apply them to Cucumber. We don't have to have the same arguments over and over again about it. Okay. I'm sort of trying to acclimate everyone to where I give a talk that it just is pictures of my cat. Eventually there's going to be that tipping point. It's probably going to be the greatest talk. Well, it will be the greatest talk I've ever given. Law of Demeter. How many people know this thing? It's really cool. How many of you go, well, you know, it's a good guideline. You know, I know when best to apply it. You know, I've been programming for 6 years now. I know when best to apply this. And I'm not saying you want to apply everything there, but this thing came from this paper, Object-Oriented Programming, an Objective Sense of Style. Style, sort of that feeling of, you know, aesthetic sense. It was a paper that they presented at Uppsala in 1988. There it is. Look at that. Did you realize that Law of Demeter is trademarked? Trademark, that's pretty cool. We need more trademarks, you know, not just Ruby on Rails as our only trademark. And so, you know, the thing they went through, and they talk about this in this paper. It's a great paper. It really is a fantastic paper to read. You know, it promises, if you abide by this style, easier software maintenance, less coupling between your methods, better information hiding, narrower interfaces, you know, methods which are easier to reuse. All of these things, you know, they're not just promised. If you've worked in a system that has a really good application of Law of Demeter, a lot of these things come true. And yet we argue about them not at a layer, or we don't argue at the level of, we have 24 years of experience with it, and we're arguing the fine subtleties. Instead, we argue like this. Law of Demeter is one of the species of the 7-year locust of the programming world. Somebody on Twitter said this, and you know, single responsibility and DCI. This is sort of how we argue about these things. I'm just going to go out on a limb and say this guy probably clearly, to me clearly, has a lack of a sense of where a lot of these things came from. You know, this is the level that we argue at, and this is the level that you end up arguing at when you don't pay attention to where these things come from. This place where we don't know what our lineage is, where we learn the techniques that we use, where we learn the principles that we talk about, what are the subtleties behind it? Was Demeter a person? You know, all of these questions that we should know, these fundamentals that we have. You know, she knows her lineage. And not just that, I'd like to kind of swing it from knowing where we come from to sort of where we're going. You know, who are the people now that inspire you? Who are the people now that you look up to? The ones that are doing great things. You know, I'm not talking... Password? I'm not talking about hero worship. I'm really talking about an honest, clear sense of admiration and emulation. Hero worship is sort of that. They can do no wrong. And that's not a good thing. And we have a lot of this in our community of people saying, no, it's too much hero worship and all that. I'd like to sort of ask you guys to think for a little bit about who are the ones that you admire. Who are people who are doing not just great things in our community, but are doing things that you would like to do. People who are you look up to and you go, wow, you know, they do this. Awesome, thanks. They are doing this one thing, and I want to make myself better. You know, it's about bettering ourselves, looking to the people that have even just one little thing that they do, and saying, I am going to do something like that. That's a role model for me. It's not a hero worship, it's an admiration. You know, you can think of it as picking one thing that person does and doing it, even for a short time. Saying, you know, there's a lot of people out there that we're like, wow, you know, they're actually doing something that makes our community a better place. Oh, no. Can you click? It's going to say, on my machine, can you click then say, yes, you can. Ah, screen sharing. And now hit Command Tab. Ah, yeah. So I was thinking about this, and I was like, who really inspires me? And I thought Justin Bieber. Because really, look at that hair. I mean, that's amazing hair. You know, I'm trying to get my hair up like that. Ah, man. No, I'm just kidding. Justin Bieber is not my inspiration for things. But there is somebody that I actually do admire and does inspire me. It's this guy. He's right over there. He's speaking this afternoon. Aaron Patterson. So, you know, he's tender. He's funny. You know, he's lovely. He's a charcutier. Makes sausages. He's a noble fighter of botulism. And he does have great hair. Look at that. And he does, and this is the inspiring thing to me. He does a crazy amount of open source work. So much. 2 weeks ago, I was writing the system for the place that I'm doing a little bit of work for. And I was like, ah, man, their interactions are with XML. And I need to run XPaths, because I had to do some checking. So I went on there, and of course I stumble upon this site called Nokogiri. And it's got the greatest tagline, that XML is like violence. If it doesn't solve your problems, you're not using enough of it. And I think about it, and I keep running into this open source stuff. And he does this crazy amount. I mean, it's a crazy amount of open source work. And we have, so there's sort of a running joke that, you know, my title's Corey Haines, and Aaron one time said, you know, that's pretty cool, so he took on that. And I thought, it's kind of funny, because there's actually a story behind me having sort of Corey Haines as my title and all of that. There was the one that Aaron saw was sort of a little bit accidental, but I used to have a mailing list called Corey's Ramblings that had like 5 subscribers to it. And I would send out, of course, emails. And I wrote an email that was at the height of that case where everybody had the, like, what would Jesus do bracelets. And I sent out an email, long, rambling email about, it's not really what would Jesus do, it's what would Corey do. And not that everybody should be about what I do, they should, but it's really about knowing what you want to do. In every situation that happens, knowing truly what it is that you want to do. And how are you going to act? Being able to say, these are the values I hold, these are the things that I want to do. And so I was thinking about this whole title thing. And you know, it's neat to have a title that's my name. I have my own company, so I can have my title be whatever I want. And I thought, you know, Aaron does this crazy amount of open source work. I would like to do. I've always said, I actually said that I want to get a promotion to senior Corey Haines. But I put on myself, I said, you know, I can't just, even though I am the owner of the company, I can't just say, bestow upon myself senior Corey Haines. I said, I'm going to get my promotion by working on open source. I'm going to get my promotion by actually going out, contributing to open source, maybe writing up some blog posts. And I had this idea that I'd like to share with you called Emulation March. And it's sort of a challenge to all of you, because keynotes are supposed to end with a challenge. And Emulation March, or Emu March, hashtag, one of my challenges to people, and to all of us as a community, is to pick a person who does something you would like to do more of. Not somebody that you're just like, wow, they're really cool. Otherwise, everybody would pick me. No, that wasn't the joke. That wasn't the joke part. No, but you pick a person who does one thing, one activity that you are inspired by, that you want to emulate. And take their name as your title for a month, for March. And then dedicate your March to doing that activity regularly. To going in and saying, you know, there's one thing that I want to do that's going to make me a better person, that I'm going to be able to either contribute to the community or just in general be a better person about it. So my Emulation March, I'm pledging to contribute to open source projects 2 times a week. I can't do it. I might be able to do it every day, but I want to take on something that is reasonable. And it might, you know, it's not I'm going to build a, you know, the new hotness gem. But even if it's just something small, contribute back to the community. Be inspired and emulate somebody that I think does a lot of good. And so there's this question of my challenge, which is there something you could do? Is there something that you could take on for just a month? And it doesn't have to be huge, but just something that you can say, you know, this person does something that I would like to do more of. I think it's very valuable, and I want to do it. So taking that up, here we go. I actually have Wi-Fi. So I'm actually, if it will type, there we go. Gonna say, hey, for a month, I'm going to be inspired. He runs on the JVM. Right? Okay, we'll change that now that I can see so wonderfully. Did it go? The joys of screen sharing. There we go. Aaron Patterson. And there's humor behind it and all of that, but I challenge you to think about those things. Think about something that you want to do more of, something that inspires you. Look back in the history. As we go through this conference, there's going to be talks about all the new hotness in the world. Think about who created those things. Did they do something that you would like to do a little bit more of? And see if you can think of something that really you could do for just a month. Maybe once a week or something. So that's my ending. Thank you for your time. I'm Corey Haines. Oh. Aaron. Oh, yeah. Thank you very much. Enjoy the conference.